Proofs Part 2. Don't forget, as you work on these proofs, that you have your Flow Proof Survival Guide. It tells you how the proof should start. It tells you how double boxes are created, extra boxes out front. And it tells you how to determine whether your proof ends with 1 box, 2 boxes, or 3 boxes. So let's look. We assume at this point in time that you've already done the first video with 6 proofs. We are working in the Triangle Congruencies and Proofs packet on the in-class proofs. So here, this is number 7. Given AB is congruent to CB, AD is congruent to CD, prove angle A is congruent to angle C. Now, every proof we do is going to have those core 4 boxes. But how did we know back here to leave space like for an extra box out front? These extra boxes out front, right here, from the double boxes, from parallel, midpoint, or bisector. So before I draw my core 4 boxes, I'm just going to look. Do the givens say parallel, midpoint, or angle bisector? They don't, which means there are no boxes out front. So I'm just going to start my proof at the left. Right? It was good to leave space for them when maybe we didn't plan ahead. But if you can look at it and be like, hey, I don't need any boxes out front, then don't leave space for them. Just move your proof to the left of the paper. So, 2 givens go in the first 2 boxes. AB is congruent to CB, given. And AD is congruent to CD, given. Third box, guaranteed to be reflexive or vertical. Vertical angles are when they have an X in the picture, kind of like this. Reflexive is when they share a side. What is this picture? This is reflexive property. They share that side in the middle. They share BD. So BD is congruent to BD by reflexive property. Now this first box needs to be triangle blank is congruent to triangle blank, and we need the rule. So let's look at the picture. AD is congruent to DC. AB was congruent to CB. BD was congruent to itself. Look at just one triangle. What rule is that? Side, side, side. So side, side, side goes here. Now, look at what we're trying to prove, though. Can this, angle A is congruent to angle C, go here? Well, no, because this has to be about triangles, and this is not triangles. So we need another box. Do we need a third box? So going back to the Flow Proof Survival Guide, first box has to be about 2 triangles. Second box would be 2 congruent things. Third box is going to say something is a midpoint or something is a bisector. Does this say midpoint? No. Does it say bisector? No. So this cannot go in the third box. It has to go in the second box. By process of elimination, it can't go in the first, because the first has to be triangles. It can't go in the third, because the third has to say midpoint or bisector. So it has to go in the second. Angle A is congruent to angle C. Now also remember that this always goes in the last box. So this is now the end of our proof. There's nothing after it. Underneath this box right here goes CPCTC. CPCTC always goes underneath the second box. I'll explain what that means in just a minute. Let's fill in this last little box. We need the order of the letters for the triangle. So I'm going to say D, A, B. I went down the side with 1 tick mark, then down the side with 2. So down the side with 1, down the side with 2. D, CB. Now this is the end of this proof. Now what about the CPCTC? CPCTC stands for corresponding parts of congruent triangles are congruent. So here's the explanation. These two triangles are congruent. That's what we just showed here. Right? So if they are congruent, or since they are congruent, then angle A and angle C are congruent because remember, they correspond. They match up. And because they match up, they have to have the same number, so they're congruent. So this part here is always going to be like a side or an angle, and CPCTC goes underneath it. Let's try another. Given IG is congruent to HJ and angle G is congruent to angle J, prove GK is congruent to JK. Quick check. Are there any boxes out front? Do the givens say parallel, midpoint, or bisect? They do not. So no boxes out front. Every proof has the core 4. So first given goes in the first one. IG is congruent to HJ. Given. Second given goes in the second box. Angle G is congruent to angle J. Given. Third box has to have vertical or reflexive underneath it. Which one is this? Do they make an X or do they share a side? Well, there's an X right in the middle, so that's vertical angles. Right there. Now we just have to name them. Angle GKI. And I purposely started at the angle with a swish mark so that I can match it up over here. JKH. All right, this box, remember, when they come together, it has to be about 2 triangles. And we need to figure out which rule is it, or which rule it is. So let's see here. Let's focus on one triangle. Maybe this one. What are the markings? Sides or angles? We have 2 angles and a side. And the side is not between, so it's angle, angle, side. Congruency. Look at what we're trying to prove. Can this go in this box? No, because this box talks about 2 triangles, and this does not talk about 2 triangles. So we need another box. Does it go here, or do we need a third box? Remember, the third box is going to say midpoint or bisector. Does this say midpoint or bisector? No. So it can't go in the third one. It has to go in the second box here. And underneath the second box always goes CPCTC. Always. If there is no second box, then you do not use CPCTC. Now all we need to know is what order the letters go in here. So I'm going to go GKI again. So 1 to 2 to nothing. Then JKH to follow the same pattern. And that's the proof for that one. Next one, number 9. SP is parallel to TR. PQ is congruent to TQ. Prove Q is the midpoint of SR. All right, let's look at the givens. Do either of them create extra stuff out front? Parallel, that does. So we do need an extra box out front. And I'm going to put it in front of the first one since it was the first given. So SP is parallel to TR, and that's given. After parallel always comes A, I, A. And it's a good idea with parallel to go ahead and make a zigzag. SP is parallel to TR. I'm going to do this zigzag. SPQ, angle SPQ, starting at the end of the zigzag, go to the other end, RTQ. So angle SPQ is congruent to angle RTQ by alternate interior angles. Next one is another given. PQ is congruent to TQ. Given. Last one, vertical or reflexive. We got an X in the middle, so vertical angles. I'm going to say PQS. So angle PQS is congruent to angle, and I went down kind of what appears to be the shorter side. So I'm going to do the same thing over here, TQR. Now if you wanted to go SQP, that's okay, but then it would need to be RQT. Both of them would be flipped. Alright, this box has to be two triangles. This says Q is the midpoint. So can this go here? No, because this has to be two triangles and that does not say anything about triangles. So we need another box. Does this go here or is there a third box? Remember, the third box here at the end will talk about midpoint or bisect. Does this talk about midpoint or bisect? Yes, it does. So there's one more box. And its Q is the midpoint of SR. Because this says midpoint, it goes in the third box here. Now that puts us in this stage of our survival guide. Underneath the third box goes either definition of midpoint or definition of bisect. And remember, under the second box, or the middle box here, goes CPCTC. So CPCTC. So how do we know whether underneath the third box is definition, midpoint, or bisector? Because this one, it says it could be either. It's based off of what this box says. This says Q is the midpoint of SR. So that means we're using the definition of midpoint. Because this says midpoint, so this should say midpoint. Now let's go back and fill in the blanks. Triangle blank is congruent to triangle blank. I need some markings here because I don't have all of them. PQ is congruent to TQ. We have the vertical angles. I'm missing my AIA markings. Angle SPQ is congruent to angle RTQ. Here we go. This looks like angle, side, angle. Focus on just one triangle. It's angle, side, angle. Congruency. And if you ever are using parallel lines, you can put the letters in the same order here from the ends of the zigzag. So triangle SPQ is congruent to triangle RTQ. We're just missing this box right here. So remember, this box has to be two congruent things. Two congruent parts of the triangles. Look at what we're trying to show. We're trying to show that Q is in the middle of S and R. Well, in order for Q to be in the middle, what two things would have to be congruent? SQ and RQ. So this says SQ is congruent to RQ. We don't mark it in the picture because we didn't know it at the beginning, but if the two triangles are exactly the same, then SQ and RQ are the same, which means Q is in the middle because the two pieces are congruent. Let's try another one. Given C is the midpoint of BD and AB is congruent to AD, prove AC is the bisector of angle BAD. So we would start with our 4 boxes. Are there any boxes out front? Do either of the givens say parallel, midpoint, or bisector? This given says midpoint. So our first box, our first row has an extra box out front. And then we have our 4. C is the midpoint of BD, goes in the first one. And that is given. After midpoint comes definition of midpoint, always. So, let's see. C is in the middle of B and D. What two things must be equal if C is in the middle of B and D? BC must be equal or congruent to DC. BC and DC must be congruent. The second given, AB is congruent to AD. Given. AB is congruent to AD. Third one, reflexive or vertical. Do the triangles share a side or do they make an X in the middle? Well, they share side AC. So AC is congruent to AC by reflexive. Reflexive property. This box is going to be 2 triangles. And for me, when I filled in these markings in the picture, very, very quickly, because I did it as I went along, I saw right away it's side, side, side. So I'm going to go ahead and fill that in underneath. Now the issue is that what we're trying to prove can't go here because this is 2 triangles. So we do another box. But this one, it says bisector, which means it actually goes in the 3rd box. AC is the bisector of angle BAD. This one says bisector. According to the survival guide, the 3rd box is definition of midpoint or angle bisector. This one's going to be definition of bisect. Because of the word bisector. Underneath the 2nd box has to be CPCTC. Now, just missing 2 parts. We're missing the triangles and we're missing what causes or what is caused here in the middle. So let's put the letters in order. Maybe A, B, C. Triangle A, B, C is congruent. So I went down the side with 2 and then down the side with 1. A, D, C. Down the side with 2, down the side with 1. Now, this part here needs to be 2 congruent things. Now, we're trying to show that AC, right here, bisects, use red, angle BAD. we're trying to show that AC bisects BAD. In order for this to be true, what two things would have to be congruent? This angle and this angle would have to be congruent, and if they were equal, then it would mean that we had a bisector. So these two angles are what go in the CPCTC box. Angle BAC is congruent to angle DAC. Now this is pretty much the worst sort of proof we could get. There's only one more level to make it more complicated, and that would be to have another box out front, which would mean both givens had midpoints, bisect parallel lines, something like that. 7 boxes, big. The biggest would be 8. We're never going to have them bigger than that. Usually they're more like 5 or 6. We have 2 more. Given AB is parallel to CD and AB is congruent to CD, prove AD is congruent to BC. We're going to have our core 4 boxes. Are there any boxes out front? Do either of the givens say parallel, midpoint, or bisector? The first one does. We're going to have our 4 boxes, and the first one will have an extra box out front. And AB is parallel to CD is given. Always after parallel, AIA. Always. So let's figure out what angles go there. AB is parallel to CD. We have to make a zigzag using the top and the bottom. It's right here. BAC is one of the angles, and from the other end, DCA. Second one, this given does not get an extra box. It's just given. So here are the AIA angles. AB is congruent to CD. The third one is reflexive or vertical. Do they make an X in the middle, or do they share a side? These share AC. So AC is congruent to AC by reflexive property. Now when you look at this, focus on one triangle. What rule? Side, 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 angle, or angle, angle, side. 2 sides, the angle in the middle. This is side, angle, side. Congruency. This box has to be about 2 triangles, guaranteed. Can this go here? No, it cannot, because this does not talk about triangles, and this needs to talk about triangles. So we need another box. What about a third box? Do we need another one? Does it talk about midpoint or bisect? No, it does not. So we stop here, and what we're trying to prove goes in the last box. Remember, underneath the second box is CPCTC. All we need to do is figure out the order of the triangles. If you make a zigzag and you followed the zigzag, you can follow the same order here. Triangle BAC is congruent to triangle DCA. Last one, number 12. Given BD bisects angle ADC and angle ABD is congruent to angle CBD, prove B is the midpoint of AC. All right, we're going to have our core boxes. Do we need any boxes out front? Do either of the given say parallel, midpoint, or bisector? The first one does. So our first box is going to have an extra one out front. And as you're working on these proofs, you're going to start finding shortcuts as you go, different ways to think. So for me, the very first thing I do is I actually draw all the boxes. So I'm going to help you do it that way this time. B is the midpoint of AC. Will that go in the first box? No, because the first box has to be about triangles. So what about the second box? Well, this says midpoint, so it has to go in the third box. B is the midpoint of AC by definition of midpoint. That's actually probably where I would start. I would then know that underneath the second box is CPCTC. I personally usually do this one fairly early in the proof. Is this reflexive or vertical? Do they share a side or does it make an X in the middle? They share BD. So BD is congruent to BD by reflexive. I then probably work up and do the next easiest part for me, which is the given that does not require the extra box. Angle ABD is congruent to angle CBD by given. ABD is congruent to CBD. Those two angles. Next, I would go to this bisect. BD bisects angle ADC is given. So here's angle ADC. And BD bisects it. Definition of bisect always goes after bisect. And we're looking for two pieces that are congruent, two things that are congruent when you take this big red angle and you cut it with BD. What you end up with are two angles that are congruent. So ADB is the first angle, and it's congruent to angle CDB by definition of bisect. So look at the picture. One triangle. Angle, side, angle is the rule we're dealing with. So angle, side, angle congruency goes under the first box at the end here. We need to know what order the letters go in for the triangle. So I'm going to go ADB, ADB, just like I did before, is congruent to triangle CDB. Last part. All I need to know is what needs to be equal for B to be the midpoint of AC. So for B to be in the middle of A and C, this piece and this piece would have to be congruent. So A, B would need to be congruent to CB. And that's the end of the proof for number 12.